Hi everyone, Becky, your science tutor here, and today we're going to have a look at giant covalent structures. So in previous sessions we've looked at the smaller molecules, but today we're going to look at where the atoms are forming massive strong networks. So if you've ever wondered why diamonds are so tough, or why the graphite in your pencil leaves a mark on the paper, it all comes down to the way that the atoms are bonded. And in this session we'll uncover how these giant structures are built and why they've got these particular properties. So let's dive in. Okay, so let's start with the structure of diamond. Now, both diamond and graphite, which we're going to focus on in this session, they're both only made of carbon atoms. So there's only one type of atom in them. You may hear them referred to as allotropes of carbon, because they're made of exactly the same thing, but how those bonds are constructed, how many bonds they have, the way that they are built, means that these two substances have very different properties. So we're going to look at today why it is and what happens to give them those particular properties. So in diamond we can see that each carbon atom, represented by these dots, each carbon atom forms 4 bonds. And something that we need to note and just recall from previous sessions is that these are covalent bonds, and that covalent bonds are strong bonds. So in diamond, because we have 4 strong covalent bonds, and we can see if we look at these molecules, if we just try to annotate them, let's put on a colour that we can see against the darker colour. If we focus on this as being our central, we've got 1, 2, 3, 4 bonds. However, then this one is bonded again. Concentrate on this central one now. This is 1, 2, 3, 4 bonds. And so all of those carbon atoms are bonded to another, whoops, let's not delete the whole thing, they're bonded to another 4, let's try to delete the numbers, another 4 carbon atoms. So if you can imagine this structure growing, we've only got a very small section there, but if you imagine how big this structure is, and we've got 4 carbon atoms, 4 covalent bonds per carbon atom, that leads for an incredibly strong structure. And diamond is one of the hardest known substances. So because of these 4 strong covalent bonds, that is what makes it have such a hard property. And because it's hard, and we could also say here, I'm going to put hard / high melting point, because this comes down to the same idea that if we wanted to melt diamond, we would have to put in lots of energy to break all of those bonds. Diamond doesn't actually melt, it would combust before we got to a temperature where it would melt, but you understand why that would need a lot of energy. And because of this property, because it's so hard, has this high melting point, etc., it's often used in drill bits. And it's used in drill bits because when that end of that drill bit is spinning around, it's going to cause friction, it's going to cause heat. However, it's not going to melt because it's got such a high melting point. And we've got that hard substance, and so it's not just going to break and crumble away while you're using that drill. So they're used in a lot of cutting tools, as I say, on the end of drill bits, and lots of questions are based around this. Why would we use them as a drill bit? Well, because it's hard and because it has a high melting point, so it's not going to break, it's not going to melt while we're using it. Now, something that I'm going to say here, but I will come back to, is that diamond does not conduct electricity. And this isn't such an issue sort of thing at the moment, but when we go and look at graphite, and graphite does conduct electricity, we'll just pop back and have a look at why is it that diamond does not, but graphite does, because remember they're made of exactly the same thing. So surely they should have the same properties. Absolutely not. Okay, so let's have a look at our graphite then. So again, only made of carbon atoms, but this time each graphite forms 3 covalent bonds. And so what you can see is it forms these layers. Now there's 2 properties in particular that are questioned around graphite, and that is 1, why is it soft and slippery? And 2, why does it conduct electricity? So let's focus on number 1 first. Why is it soft and slippery? And this is what makes it useful in pencil leads. Because those layers, when you run your pencil across the paper, essentially what you're doing is you're rubbing the layers of the graphite off the sort of end of the middle of your pencil, and it's leaving those layers behind on your paper, and that's why you see the mark, the trace that you've left. Okay, so we're going to say that it forms layers, and those layers can slide across one another. So just like when we talked about metallic bonding, in those layers slide. And I'm just going to note here, if we just pop it in a different colour, this is why it is described as soft and slippery. You can see in the diagram that we've got the layers and these little dashed lines between them. These are our intermolecular forces, and we know from previous sessions that our intermolecular forces are weak. So it doesn't take much energy to break those forces. So when we're using our pencil, it doesn't take much energy for those layers simply to slide over one another and leave that trace on our paper. Now the second property that we often get asked about is why can it conduct? Okay, so what I want you to do first is to think about the structure of carbon. So carbon is mass number 12, proton number 6. So it has 6 protons, therefore it will have 6 electrons. 2 in the first shell and 4 in the second shell. Whoops, that's a bit of a wobbly one. Might try that again. So all I'm going to do is just represent the outer shell. Okay, my 4 electrons in the outer shell. Now remember that this time each carbon is bonded 3 times. So if I simply bond this to another 3 carbons and I share those electrons, remember we're talking about covalent bonding, got shared electrons, what this does is it means that each carbon then has 1 free or spare or delocalized, whichever term you want to use, but it has 1 free electron. So each of those carbon atoms basically has 1 spare electron, and those electrons become delocalized, and just as we've talked about again in metallic bonding, delocalized electrons can move through the structure, carry the charge, and therefore can conduct. Okay, so let's make a note of that. So we have delocalized electrons and that means that graphite can conduct. Now if we very quickly pop back to our diamond, we've put, oh, I've put does conduct electricity. I hope you guys spotted that earlier. Does not conduct electricity. We said we'd come back to it, didn't we? So if we do a little outer shell of 4 electrons each again, and remember this time it's bonded 4 times, so each one of those electrons is going to be bonded or shared with another carbon, and therefore it has no free electrons. So although it's made of exactly the same substance, it's all just carbon, because it has 4 bonds, each electron is involved in bonding, and therefore we don't have any free electrons that can move through the structure. Whereas in graphite, each carbon has 1 spare electron, becomes delocalized and can move through the structure. So you can see there, although we've got two substances that are made from exactly the same thing, that simple change in the way that they are bonded means that diamond is incredibly hard and cannot conduct electricity, whereas graphite we would describe as being soft and slippery and can conduct electricity. Okay, so what you will often see is exam questions will throw in something out of context, and that's something that I'm always talking about. Once you've got that knowledge, make sure you can apply it to something out of context. And so often you will see structures such as Buckminster fullerene, which we're going to have a look at in a moment, and you may see graphene. So graphene is just a single layer of graphite. And what happens is that students often come across a question like this and have a little bit of a panic because they think, oh, I haven't seen a Buckminster fullerene, I don't know about it. But use the knowledge that you've got. Again, it's made only of carbon. This time it is structured so that it's spherical in shape. And if you focus just on one of the carbons for a second, so this red here is representing 1 carbon, we bonded once, twice, 3 times. So if we bonded 3 times, that means that each carbon has a free electron that can become delocalized, and therefore Buckminster fullerenes will be able to conduct electricity. Now, the property that is most spoken about with Buckminster fullerenes is that they are often used as lubrications. Now, I've put this one in particular because straight away you might be thinking, well, if it's used as a lubrication, that means it's soft and slippery, which automatically kind of diverts you back to graphite because of those layers. However, the reason that Buckminster fullerenes can be used as lubrications is because they are spherical molecules, so they're round. And they can roll across one another. Whoops, one another. Yes, if we just think logically, if we had, I don't know, a set of marbles on a desk and we placed something on top of those marbles, it would be easy to move that along because those spherical marbles underneath would simply roll and cause it to move easily. Yeah, so it's a little bit different with the Buckminster fullerene, and that's why I wanted to show you it, but essentially the same thing. And as I said, if you see something a little bit different, don't panic, okay? This is a sheet of graphene at the top, so this is just a single layer of graphite. This is graphene, and here we've got a nanotube. And our initial reaction is to look at them and think, oh, well, I haven't been taught about those. I don't know what graphene is. How do I know what properties graphene is gonna have? It says explain why it can conduct electricity. I don't know. I haven't been taught about it. Use what you know. Have a quick look, take it out of context, but let's have a look. 1 carbon, bonded once, twice, 3 times. It's got 4 electrons in its outer shell. 3 are involved in bonding. It must have 1 spare electron that can, or becomes delocalized and can move through the structure. Therefore it can conduct. It's also a very strong material because remember that we've still got covalent bonds, and covalent bonds are strong. So the sort of linear strength of it, if you like, if you tried to pull that apart, it would still be an incredibly strong substance. Okay, but very thin because we're only talking about 1 atom big, and can conduct electricity. So these are often used in things like touch screens because it can conduct, but it's still got a relatively good strength behind it. Okay, so if you do see something out of context, don't panic, just use what you know. Use the fact that you know if it's bonded 3 times, it's going to have a delocalized electron, therefore it can conduct. If something has got delocalized electrons, whether we're talking about metals, whatever, it gives them the same properties. So use the knowledge that you know and apply it to that unfamiliar situation. Okay then guys, now we've got that sort of fundamental knowledge, let's have a look at some exam questions and how we would apply it to those questions. So we're going to start out as always with some lower level questions. Again, we need that knowledge, but the demand of the questions is slightly lower. So here we've got the question about substances containing carbon atoms. So could ask us about diamond, could ask about graphite, or sometimes and quite often they ask about both because it's about that comparison. So first of all, we've got diamond, and it says it is used for the tips of drills, and give one reason why diamond is used for the tips of drills. And either answer that we spoke about here earlier, the fact that it is hard or it has a high melting point, either of those would be accepted. Then we've got graphite, and again it tells us it's made of carbon atoms. We've got a diagram to help support us. What type of bonding do we have? Well, if we're unsure, just think about our rules of bonding. Carbon is a non-metal, so therefore we've only got non-metals involved in that bonding, therefore we must be covalent, so they're going to share those electrons. How many carbon atoms does each carbon atom bond to in graphite? Diamond it is 4, graphite it is 3. Okay, so here we've got another question that is asking us about the properties. So it says that diamonds are found in meteorites. Meteorites get very hot when they pass through the Earth's atmosphere, but the diamonds do not melt. And this is because diamond has a high melting point. Most diamonds found in meteorites are nanodiamonds. A nanodiamond contains a few thousand atoms, and then diamonds are used for the end of drill bits. They're used for the end of drill bits because they are hard. The figure below shows the arrangement of the atoms in diamond. Diamond is made of only carbon atoms, and each atom is bonded 4 times. If you forgot that, we could count that using that diagram. Remember, if there is a diagram there, it is there to support. It will probably help you with some of your answers. Use the diagram, read the information that's there. Diamond has a giant covalent structure, and in diamond all of the atoms are bonded together. Just move that out of the way a second. Oh, we could see it all. So all of them are bonded together, and that's why we get that giant strong structure. Okay, on to sort of a mid-level question then here. So now we're having to explain why we have the properties that we have. They were just very basic questions about the structures, etc. This is now getting a little bit deeper. Why does it have these properties? So here we've got diamond and graphite. And it says they both contain the same element. What is the name of this element? It is carbon. Okay, and then again, use the diagrams above. Yeah, they are there to help. It is even hinting to you to use those diagrams. Use the diagram above and your knowledge of structure and bonding to explain why graphite is very soft. So this is worth 2 marks, and the first mark comes from ideas around that they are in layers, and it's about those layers that can slide over one another. So over one another or over each other. So that's for marking point 1. And the second marking point comes from the idea of those weak forces between the layers. Yeah, because it says explain. They can slide over each other because between the layers there are only weak forces. Okay. So why is it that diamond is hard? Okay, so again we're going to, first marking point is to identify that each carbon forms 4 covalent bonds. Okay, and then, okay, yeah, so then we're going to add in that the covalent bonds are strong. So we're identifying that we've got lots of strong bonds in there. And then on to the final part of the question, why does graphite conduct electricity? This is about the fact that it contains delocalized electrons. So that is for marking point 1. And again, the idea is like, yes, so what? It's got delocalized electrons into marking point number 2, which can move through the structure. So they can move through the structure carrying that charge. Okay. So lots of questions, typical question, lots of questions comparing diamond to graphite. Okay, now this question takes it back a little bit and brings in a little bit of atomic structure. So it tells us that carbon has 6 electrons, and to show the electrons using crosses. So it's testing our knowledge, knowing that we can have 2 electrons in that first shell, and therefore we must have 4 electrons in that outer shell. Now here it shows us the cutting end of a drill bit. It zooms in a little bit on the diamond that's on the end of the drill bit, and then shows us the structure of the diamond. And what property of diamond makes it suitable for cutting the cutting end of a drill bit is the fact that it's so hard. It's not going to wear away, and therefore as it's spinning around, breaking down the material that you're cutting into, it's not going to wear away your diamond, and therefore it helps the drill bits last longer. And then it's this question, it says explain as fully as you can why diamond has this property. So why is diamond hard? Use your knowledge of the structure and bonding and the information showed opposite to help you answer the question. Okay, so we're going to talk about the fact, first of all, for marking point 1, that it's a giant covalent structure. Because the question implies use your knowledge of the structure and bonding. Well, it's not a simple covalent structure, is it? Because they are only made of 2 or 3 atoms. They've got low melting points, etc. So we're going to identify and show that we know that giant structures have these properties. So we're going to say it's a giant covalent structure. We can pick out, there are a number of marking points here, but let's think logically about it. We want to now sort of reiterate why is it hard. Okay, so we're going to say it has, each carbon atom has 4 bonds. And we're just going to back ourselves up and say that these bonds are covalent bonds. And remember, don't worry if you've put them in a different order or anything like that. Whatever makes sense to you, these are the key points that the examiner will be looking for. So here we're identifying that it's made of covalent bonds, each carbon's got 4 of them, and we've got a giant structure, and therefore that all combined, the number of strong covalent bonds we've got means that that substance is hard. Okay, so let's take it out of context then. So here we've got a nanotube, and it tells us that the bonding is similar to graphene. So we need to be thinking, well, we know that graphene is a single layer of graphite, and therefore they're going to have similar properties. So it tells us that carbon nanotubes are used in electronics because they conduct electricity. Explain why. So this again is about the fact, so 2 marking points, we need to identify that they contain delocalized electrons. And then back it up, so what? They contain delocalized electrons. So we're going to further that and say that these can move through the structure. So they're pretty standard answers. We're just taking it into a different context. Okay, so here we've got a little bit more of a sort of extended answer here. So here we've got graphite and fullerenes are forms of carbon. And it says that graphite is soft and a good conductor of electricity. Explain why graphite has these properties. So we've talked about the conductor bit already. Whoops, sorry, jumping ahead. And then let's look at why it is that why it's soft. So answer in terms of structure and bonding. So the idea is that here we need to identify that graphite has got the 3 carbon bonds. So we'll say that each carbon has 3 bonds. Yeah. We want to talk about the fact that in the bonding it forms layers, and those layers can slide over one another. So the layers can slide, that's what makes it soft and a good conductor of electricity. We've got those 3 bonds, so it can conduct because of the delocalized electrons. Whoops, that should be an A. Yeah, so a bit more of an extended question, nothing we've not seen before, but asking us 2 properties this time. Okay, I've put you in an example of the Buckminster fullerenes just so that you've got an example and you've seen it in an exam context. So a lubricant is a substance that allows materials to move over each other easily. Suggest why Buckminster fullerene is a good lubricant. So this is the idea around that the molecules are spherical. Remember, if you word these answers slightly different, the molecules are spheres, that's okay. It doesn't need to be word for word. Remember, these are all ideas around. So it's just giving an idea, explaining that you know that these molecules are round, or that they're spherical, or that they're sort of spheres, however you say it. And again, it's kind of like, yes, so what? They're spherical, and that they can roll. They can roll across each other. The molecules will roll, they will roll, they can roll across each other. It's the rolling part that's the second bit that we're looking for marking point 2. And then one final question. So here again we've got a little bit of a higher level question. We've got 4 marks, and this time we're talking about the drill heads that contain diamonds, and describe as fully as you can about the structure and bonding. So what is it that, why do they contain, or why should I say, why do drill heads contain diamonds? Okay, so we're going to identify first of all again that it's a giant structure, and if you've got in your mind that you talk about it being a macromolecule, that's fine, yeah, as long as we're identifying, again, it's ideas around that it's a large structure. So we've got a giant structure, and we're going to say that each carbon forms 4 bonds. You see how these answers, we feel like we've already said them, because once you've got that locked in, once you know why, it's the same process. Each carbon forms 4 bonds, somewhere that they are covalent bonds. So if you put that in a sentence, each carbon forms 4 covalent bonds, that's 2 marking points. And we want something about these are strong bonds. So again, if we, finish that off before I start talking. If we said that drill heads are hard because diamond is a giant structure, each carbon in the structure forms 4 strong covalent bonds, that would still get us those 3 marks. We've kind of narrowed it down into sort of 2 sentences there, but each carbon forms 4 strong covalent bonds, that will still hit those second 3 marking points, so that will get us the 4th mark. Okay then guys, as always, if you would like any further support, please do feel free to reach out. Hope you found that helpful, and I'll see you next time.